Now, one of the things that you'll see is that hex addition is a little bit tedious, but hex subtraction is easy, comparatively speaking. So here's the way it works. If you have this digit, which is D, is bigger than B, you have to borrow. And where you borrow from is this guy. So you borrow 1 from the A is 10, 1 less than 10 is 9. And what we do is we slide a 1 over here, and this becomes a 1b base 16. Well, 1b base 16, that's 16 plus 11 is 27. 16 plus 11 is 27, and we're subtracting D, and if you remember D here is 13. So we subtract those two, we get 1, 4. We look that up, that's 14 is E. We've already done half of our subtraction. Now, we have another problem here because C is bigger than 9. Now, just like when you don't have enough money, you go to the bank. So what we do here is we take out a loan, we take out 1, we set the carry so we can borrow from it. So if you borrow $1,000, then you use $1,000. What you owe and what you use balance out. So these two cancel out, but what we have here now is this column is now not what it was before. It's 16 plus 9, or 19 base 16. 19 base 16 is 16 plus 9, and if you do the math, that's 25. 16 plus 9 is 25. Subtract C, which is 12, and that gives us 3 and 1. So that's 13, which when we look it up is D. And that is how you do subtraction. If this number is bigger, you borrow 1, reducing this by 1, and you slide 1 over is 1b, which is 16 plus 11 is 27. Subtract this, gives you 14. If this digit is bigger than here, you set the carry so you can borrow from it. That's why it's called either a carry when you're adding or a borrow when you subtract. This says you borrowed. Here you are borrowing 16 plus 9, 25, minus 12, 13. There's your answer. Now, this is a fairly easy subtraction. Let's look at the most complicated subtraction I can ask you to do. Let's take a look at this number, 0, 0, subtract AB. And this is what I call the hardworking Bob and lazy Joe scenario. And Bob has always said that good, honest, hardworking people get done in by lazy people. So here's Joe, and Joe says, well, I need to borrow. But Bob here says I got no money. So Joe tells Bob, go to the bank. So Bob takes out a loan, and now Bob has $16. Here's his borrow, he now has 16. Now lazy Joe over here says, oh, you got $16, let me borrow from you. So 16 for Bob now becomes 15, and Joe, the lazy guy, has all the money, he's got 16. So this becomes 16 minus 11 is 5, 15 minus 10 is 5, and there is your toughest subtraction you can possibly ask to do. Now when you're subtracting in binary, the easiest way to do this is to actually convert the values in binary to hex, do the subtraction, and write it back. So let's see how we can go about doing that. So this number is 4 and 2, that's 6. And 8 and 4 and 1 is 13. And this is again 13. And this number here is B. Now right away you can see that once you get good at doing these conversions, this number here is 13 minus 11, which is 2. So you got half of it done already. You have to borrow because the D is bigger than the 6. And then you use it. So these balance out. So 16 plus 6 is 22 minus 13. And once you got that, the answer is 9. And when you do this, then you can write the answer back as a carry. 1, 0, 0, 1, 0, 0, 1, 0. This is the fastest and most accurate way to do it. So our answer, let's just write it over here so we remember, this is a 1 in X, 9, 2. So just to remind ourselves. So here's what it does, because digital circuitry cannot subtract directly. It uses a trick. So here's what the digital teacher will tell you, is you take this number and you put it through 8 inverters. Because digital circuitry as inverters. What does an inverter do? Well, all ones become zeros and zeros become ones. So this is 0, 0, 1, 0, 0, 1, 0, 0. This number you have here is called 1's complement. Okay? And 1's complement, if you add 1 to that, this becomes a 2's complement. 0, 0, 1, 0, 0, 1, 0, 1. And the 2's complement, as we'll see later, is the negative of this. Then what do they do? Well, then they say, okay, well, let's get rid of this guy and turn the subtraction into an addition. So let's get rid of our inverters here. Let's take this number back and we're going to add that back to here. So this becomes 0, 0, 1, 0, 0, 1, 0, 1. And if we do this again, 1 and 1 is 2, which is 1, 0, 0, 1, 2, 2, 0, 1, 2, 2, and 1. And notice our carry here is not right. So we've got 9, 2, just as we had before. But what the digital circuitry is smart to say is, even though we have a 0 carry, it's smart enough to realize that you were doing a subtraction, not an addition. So what it's going to do is it's going to run this through an inverter and actually give you a 1. So the intuitive result we came up with, which is 92 with a carry, is exactly what the digital circuitry will come up with, but I think you'll find that this way of doing it in hex is a lot quicker to get your binary subtraction.